want to let everyone know that we will have a little time at the end for a brief Q&A with Simon. So if you have questions about the presentation, please make sure to drop them in the Ask a Presenter tab in your chat menu for any questions, and then feel free to use the other chat to introduce yourself, share your LinkedIn profile, or make any comments about the session. And with that, Simon, I will let you go ahead and take it away.
Thanks, Megan. Yeah, very excited to be talking to you today about scalable lakehouse architectures with Iceberg and Polaris. I'm Simon. I'm going to talk a little bit more about what I actually do later. Before that, I actually want to get to know the audience, you, a little bit better, because we're going to spend the next 45 minutes talking about a very interesting topic. And I think, Megan, you've set up a little poll, right? I was interested, who has actually used Apache Iceberg tables in their day-to-day? Do you guys see the poll? Because I can see my slides. I hope so. And the second question I would have is, who of you knows about the DLT library for data loading? Because we're going to be talking about that too today. Megan?
Yeah, so your polls are launched and we've got some responses. So it looks like to your first question here, who has used Apache Iceberg tables in their day-to-day? 38% say that they have, 21% said they have not, and 41% said they were thinking about it. And for who knows about DLT for data loading, 21% said they do know, and 79% said, what's that?
Okay, so I think we definitely have one for the last group who don't know about DLT yet. And hopefully there is a big sort of like overlap between the ones who've used Apache Iceberg tables already, but who don't know about DLT. So I think there are a bunch of very cool synergies to leverage when you use both of them together. And that's what we're going to get into. And we're going to look at real demos of how to do that when we talk about scalable lakehouse architectures. To kind of start with a little icebreaker, I think we've all been in that situation. When we were small, we always thought what we want to be once we grow up. Maybe some of us thought we want to be a millionaire, a firefighter, maybe also a rock star. Maybe some of us already back then wanted to be a data person, but certainly none of us wanted to be a bottleneck. How come that most of us as data people end up being a bottleneck? I'm also a data person working at Taktile, so I'm going to be talking about that a little more later. And I see myself or find myself as a bottleneck for 3 reasons, usually. The first reason is too many tickets, competing priorities, hard to prioritize. The second reason is too much data, and like the scale of data just grows out of hand. This is what we're going to be talking about today. And the third reason for being a bottleneck is complexity of the tools that you use. And that's what we're trying to avoid with the tools that we're going to be looking at today. So the focus is really on creating scalable architectures to process large volumes of data with flexible tooling. A little bit about myself. So I have a background in machine learning and data science. I've been leading the data and analytics team at Taktile for the last 3 years. When I don't do that, I really enjoy drinking coffee and riding my bike. And the company that I work for currently is Taktile. Taktile is a low-code decision engine for fintechs. So if you want to get a loan from your bank needs to make a decision whether you're creditworthy, and that decision can be orchestrated in a low-code way on Taktile. Company's background is in AI and fintech. We've been around since 2022. We're used by a lot of the big names, Nubank, Allianz, and a few others. We have about like 120 customers, and we're backed by renowned investors. And that kind of sets the scene for what I mean when I talk about large data volumes cause my team to become a bottleneck. And this is what that means for us as a data team. What you're looking at here is how hypergrowing business produces hypergrowing data. So since the beginning of last year until end of last year, the volume of events that we ingest into our largest event tracking table, which we currently do in Snowflake, which we used to do in Snowflake, grew by 12x. And so we saw like this is, even for today, this is not scalable, but we want to scale the product into a whole different dimension, and we need to be able to ingest events at a rate of 1,000 events per second, and we definitely needed to do something about that. Before I talk about and actually show you what we did about it using Apache Iceberg tables, I want to shed a little bit of light on where we came from. We had a very traditional data warehouse architecture. That's what we started with as a data team. What this means is we have an API that collects events from our product. Like our customers send us API requests. We collect those API requests, put them into a buffer, and from that buffer, we send them into our data warehouse using Lambda functions. And I think the benefits of that, like very native, like warehouse native architecture is we have the fully managed infrastructure. We get like query optimization, partitioning, all the performance optimization off the shelf. The limitations is what I just talked about, right? It's very expensive to load that amount of data that we were looking at here. And it's also, if you want to archive your data, if you want to move it elsewhere, you're always bound by this tight coupling between storage and compute. So that's what we needed to get rid of. We needed a solution to decouple storage from compute. For one, to be able to move our data more flexibly, and for two, to save cost. And to be even more specific on how this created problems for us, I've created a bit of a more detailed architecture diagram here. On the top, you can see what I'm going to call the producer. This is literally our platform. There are a few Lambda functions running that produce those events. Those events end up at the API gateway down at the bottom left. That is our analytics pipeline who collects those events, buffers them, and processes them. And the processing means we send them to Snowflake. Like we're literally shooting insert into queries directly against our warehouse, and that loads them into a table. The problem with that is, and if you look at the chart here on the right, that's when I ran like a little benchmarking just before this presentation, where I send events through this infrastructure, as we see it on the left, at a rate of 100 events per second. And that rate of 100 events per second is what you can see on the blue line. The orange line is at the speed at which we can actually write those events to Snowflake, which is a third of the velocity at which we receive the events. Well, now you might say just scale up your warehouse, but as I said, our goal here was to like save money, not spend more money. And the consequence of that is then to actually eat through those 60,000 events that we send over the course of like about 15 minutes, we take almost twice as long until the last of those events has actually made its way into the warehouse. which means we're building up a delay of about 7 minutes just within this small time frame. And how, I mean, I think now it's obvious how this creates problems for us. We don't have a need for real-time data at our company, but we definitely cannot afford to have events being stuck in the queue for more than 4 hours. And that was the situation until like at the end of this year. Throughout the day, we would build up a backlog of events that was longer than 6 hours. So we had to rely on downtime during the night to actually eat through that backlog. And if you'd have had one more customer signed up, I think the night would have become too short to actually eat through the backlog. So long story short, we needed to do something, and we were looking into Iceberg. So if you look here at the left now, what did we change? We swapped the native or the internal Snowflake tables with Iceberg tables. The benefit of that is we can directly write to those Iceberg tables from Lambda functions. So you have much more flexibility on the horizontal scaling of these Lambda functions, which means that we can write events at the same velocity as we receive the events. So again, the write velocity is the orange line, the receive velocity is the blue line. There's barely any backlog building up in the buffer, and we still, with the catalog integration between Iceberg and Snowflake, we can still get most of the benefits of query optimization, etc. We can actually query data across different sources. So we not only have Iceberg tables, we still have internal Snowflake tables for data sources that have lower volumes, for example, like all the entities from our CRM. But for the high volume ones, we can use Iceberg tables. Yeah, this is just an updated version of the infrastructure diagram. So you remember in the last one, we were writing to Snowflake directly from this Lambda function. Now we've put in a bucket in between where we create those Iceberg tables and then just reference the data and metadata through the Open Catalog integration. Now you might want to know, like, how do you actually create these Iceberg tables from a Lambda function? And that's where DLT, the library that I mentioned in the beginning, comes into play. And I actually want to show you how easy that is, how easy it is to create those Iceberg tables from a Lambda function. And I have prepared a little demo. In here, you should be able to see my code editor now. Let me actually zoom in a little bit. So what we have here on the left-hand side is a Lambda function, like we're on AWS. This is a Lambda function. It works the same way with GCP Cloud Functions. It has 50 lines. And what it does is it receives events, like a batch of events. It does some grouping of those events depending on what type of event we have. And that's pretty much it. Then it takes those events, creates them as a source. So here you can see the DLT library. It creates a source from those events. It creates a pipeline object. A pipeline is nothing different but a definition from which is the destination that you actually want to load your data to. In our case, that's an S3 bucket. And then we can just say pipeline.run on that source. And all the normalization, column migrations, the metadata creation, that's abstracted away, and that's happening under the hood. It's taken care of by DLT. And on the left-hand side here, you can see some CloudFormation code, which we use to deploy this Lambda function behind an API gateway. So we have pretty much the same architecture that we had here. We have an API gateway, we have the Lambda function, and then in here we have DLT running to put those events into a bucket. And let's see how this works. So if I've deployed this, all right, we have the endpoint of the REST API that we can send those events to here. And if I now go over to editor, prepared a little notebook where we can send sample events to that endpoint. And to make a realistic case, I think most of us are data people, and given that, I think most of us have gone through the DBT YAFL shop example. So we're using a flavor of that. We're creating order events, and later on we're also going to be creating items like that belong to those orders to create at the end of the session a little revenue forecast for our imaginary YAFL shop. But for now, we want to demonstrate how we can use this Lambda function that runs DLT behind this endpoint to write events to an Iceberg table. So I'm going to start sending these order events. I've created them ahead of time and put them into local CSV. And while this is sending events to the endpoint, we can jump over to the bucket. So this is the bucket we want to create our tables in. I hope this works. Okay, let's sign in again. There we go. All right. Let's go to the bucket. And there we go. So this bucket used to be empty, but the Lambda function did its job, and it's actually created the Iceberg tables in here for those order events. We see we have data and metadata in here, but we don't want to inspect this data, for sure not through the AWS console. The cool thing about DLT is that it comes with a CLI, so we can use DLT datasets, dataset list. And there we see 3 datasets. Well, why 3? Let's look at DLT in a bit more detail. It has this declarative config file where we can define datasets. We've just used this one data set here, our Iceberg example, where we put the events. But for the whole demo that we're going to do here with like the orders, the items, and eventually also the underlying fact and dimension tables, we have 2 other data sets, which is the raw data set for those entities, in our case, the items that we can purchase, and the YAFL shop, like the gold data set where we want to put our model data in the end. But for now, let's focus on this like Iceberg example, which is the landing zone for our raw events. And we can do DLT data set. Take this one, and then we do a row count on it. We should be logged in. Let's try it again. So it's reading the metadata and the catalog information from the Iceberg tables that we've created. And there we go. We've created 636 order events in this table. And we can even look at these order events. So instead of doing a row count, we can do a head on the order table. Look at the first 5 rows. So this is the first 5 orders that we've just sent through that Lambda function into our Iceberg tables, and now we can query it directly in our CLI with this with the DLT package. Order ID, order date, the underlying item ID, and the quantity. I think that was a very brief demo of what we've been doing to swap our infrastructure from internal Iceberg tables to the from internal Snowflake tables to those Iceberg tables, relying on DLT for the convenience. And as you can see, we spent a single penny on Snowflake compute. In fact, all of this ran on my laptop and on the Lambda function, and that was also the effect that we were able to realize by making this infrastructure change. So in our previous warehouse architecture, we were spending 70% more, mostly because of the compute expenses down here. And now we're spending a lot less. Of course, we have to pay a little bit for the storage here, but we were able to cut the compute cost entirely. This session is titled Scalable Lakehouse Architectures. So we not only want to talk about data loading, we also want to talk about data transformations. And most of you probably feel familiar with this. A select star can become very expensive, but it's not as expensive if you do it on commodity hardware. So this is the topic of the next couple of minutes. How can we use DLT to run transformations on this raw data that we've just created, and run those transformations in memory on commodity hardware? We're going to do it on my local laptop here, and then only push the results of those transformations, these golden data sets that we want to share across the company, across stakeholders, into our warehouse destination. In our case, that's going to be Snowflake. As I said, only the transformed and maybe aggregated data. So how does this look like, and how does DLT enable these local transformations on top of Iceberg tables? So we have an Iceberg table. We have a declarative definition of those transformations that we want to run in DLT, and then DLT pulls the data down and runs the transformations in that are defined in dbt, in our case, in a local DuckDB instance in memory, and only the output data sets that we specify with this declarative syntax are then pushed to the destination. In our case, you see here destinations, there is a warehouse destination down here on Snowflake. And then at the end of the day, we have beautifully and accessible data sets in our destination. So let's switch back over to our IDE to see how this is actually done. Before we run the transformations, we still need to get item data into our warehouse. Right now, we only have the events in there. We saw there's only this order table. We can use a DLT pipeline to do that. So we have locally a CSV file with those with information about the items that customers can order, and there's a pipeline defined. If I do DLT, let me zoom in a little bit. DLT pipeline list. There's one sync shop entities to Lakehouse. It's a pipeline that is specified here under the sources. It's very similar code to what you've seen in the Lambda function. We have a source nested in that source. We have a resource for items, and then all we have to do is to run this source through a DLT pipeline, which is again what we've specified in this declarative YAML file in here. So we can do DLT pipeline run, pipeline name, put that pipeline run, So you see we are normalizing, extracting these items, and eventually loading it. And we've loaded it to, where is the pipeline? Here's the pipeline specification. We've loaded it to this YAFLeshop entities raw data set. So let's inspect that. BLT data set row count. Row counts should be 20 items in there. Yes, so there are 20 items in this table. And now let's talk about transformations, because that was the original purpose of this this second part of the demo. We have two transformations defined in here. One for our entities, in our case, that's just the items that customers can order, and for the events, so for our order events. And over here, I have two little DBT projects with define what those transformations should actually do. We have staging data set in here, and we have a dimension model for our items, and we have a staging data set for our orders and a fact model for our order events for those of us who are into dimensional modeling. So now let's run those transformations. Again, the source data is sitting on an Iceberg table in S3. What's going to happen now, we're going to run transformations on those Iceberg tables. The staging data is going to reside in memory on my laptop, and we're only going to push the fact and dimension tables, the golden data sets that we want to share with the company, to our Snowflake destination. DLT transformation list. Then let's run the entity transformation first. Run. This takes a while. A little while. While this runs, we can actually jump over to Snowflake. So right now, this is my development database. There is nothing about YAFLeshop data in here. Let's wait for the first transformation to finish. We can see it's running in a local DuckDB cache. So no money spent on hyperscaler compute. It's done. Let's refresh our page. Right, we have a YAFLeshop dataset here now, and it has the items dimension table. Let's also load the entities, the events transformation. Events. That's also going to take a little while, so it's a little bit more data. Still waiting for it. There we go. Let's refresh, and we should have a second data set. Yes, our fact table for orders. And what I could do now, I can actually I can query this data. I can go here and say, yeah, select star from my database, YAFLeshop orders. If I do that, I see that it's the same 636 orders that we've seen in the raw data. So we can put a check mark behind this. What we wanted to do is like run transformations on top of Iceberg tables, do the intermediary step locally on commodity hardware, and only push the results of those transformations to our warehouse. But what if we have consumers in our companies that are data scientists that are not necessarily that familiar with SQL and how to do database ORs, etc. They just want to use Python to build predictive models. And DLT also has a good answer to that, because DLT does not only come with the CLI that we've just seen, it also comes with a Python SDK that allows you to access these data sets in a very Pythonic way, and essentially in a few lines of code build a predictive model from the data sets that you've created using the library. And let's jump back to our IDE and look at how to actually do that with the order events that we've created. I'm gonna scroll down in my little notebook here, where I've created this section to build a simple forecast model for future revenue for the shop that we are running here. What I'm doing is I'm importing this Lakehouse project. What is the Lakehouse project? That's not a Python library on PyPy. You could put it there if you want to, or you could put it on your internal PyPy. But this is the project here, the DBT project, packaged up as a Python project. And that packaged up Python project comes, for example, with a data catalog. So I can inspect that data catalog just as I was able to inspect it using the CLI. And we can see there is 3 data sets in there, and this Yaffelshop data sets actually sits on Snowflake. And when I want to read data from this Snowflake data set, our fact table of orders and our dimension table from the items to build a predictive model, all I need to do is to reference these data sets from the catalog as a pandas data frame. So let's do that. So we see this is the same data that we just saw on Snowflake, pulled into our local Jupyter notebook with 2 lines of code and a bit of transformations. What do we do here? We multiply the order quantity from the orders table with the price amount from the items table to actually get the daily order volume. How does the daily order volume look like? You see it's growing over time, which is great. The shop is doing good. And there is some fluctuations in there. And actually, when I created this this fake data, I put in like a weekly seasonality, like with spikes on weekends, and yeah, a month-over-month growth rate of 10%. So let's see whether we can put a predictive model on top here to capture those seasonalities and see. I mean, this time series ends right before Christmas. So let's see whether we can predict the holiday season sales. If I look at the forecast, you see it like got the weekly seasonality, it got the month-over-month growth rate, and yeah, we keep on growing. And if you look at the trends here, it's pretty much the same. It's just a little yeah, funny modeling exercise to show you like how to what it actually like. It's not only about building a scalable lakehouse architecture that can handle large volumes of events by plugging in an Iceberg table. It's also about creating transformations in a way that's scalable and flexible, and sharing your data with stakeholders in your company that's very scalable and that breaks entry barriers down as much as possible. And yeah, I think why we chose DLT for us, I think it fits very well into the 3 principles that we have for building scalable infrastructure. It's the modularity. You can plug in anything that speaks Python with DBT. It's based on open standards. I mean, that's the topic of this talk, right? It's about open table formats, Iceberg tables. It's about an open source query engine, DuckDB, and many more. And it's portable. Like everything I showed you, you can essentially pip install. Everyone on your team can do that on their local laptop. Yeah, and I think that's it from my end. This is not my current team. It's more than my current team. It's the current company we're hiring. So if you're out for a new challenge, if you want to work on interesting stuff with Iceberg, we're not only plugging it into our analytics stack, we're actually also plugging it into our product. Check out our careers page. And yeah, thanks a lot for the interest. Thanks a lot for the attendance, and also thanks a lot to the selection committee. And I think we have a few minutes left for Q&A, if I'm not mistaken.
Yeah, we've got a couple minutes left, and there were a couple questions that came into the chat. So let me just go through the list here. So we've got, our first question says, you suggested you cut warehouse compute costs to 0 by shifting to the Lakehouse architecture, but where did that compute go? My understanding was that you were referencing the Iceberg Catalog via Snowflake, so presumably that compute is happening somewhere. So where is it?
Yes, that's a very good question, and let me go back to this slide. So this is the old world, and we're actually like we were paying compute twice. So what was happening is there was like for each batch of events, there was a Lambda function running, and that Lambda function ran queries against Snowflake, and Snowflake was spinning up warehouses to process these queries. So we paid for the Lambda compute, and we paid for the warehouse compute for those events to end up in the table. Now we still have the Lambdas running, and we still pay for that compute, but we don't have this second like intermediary layer where we have to pay for compute again, because we create the tables as intermediary tables. This is only for the loading part. When we query those data sets using Snowflake's query engine with the Open Catalog integration, we do need to pay for compute, of course, but just for the data loading part and for creating these Iceberg tables, we don't need to.
Okay, awesome. So we do have two folks that wrote in and asked if the code is open sourced and you had a demo link or a URL or something you can share, because it looks like a couple people are working on something similar, so they'd like to try out what you've presented. Is that something that's available?
Yes, that is both the repo where I demoed how the Lambda function is being deployed is available. That's under my GitHub. And the portable data lake demo that's available under the DLT hub GitHub. Yeah, I'm not sure what's the best way to share these URLs. You will definitely find them when you Google them, but this is all open source, yeah.
Okay. And then it looks like we've got one that just came in, says where and how is the Polaris coming into play in the architecture?
Yes, that is a very good question. I didn't explain that a lot. So DLT Plus has that's the like commercial version of DLT that has a built-in integration with the Polaris catalog. So you can reference when you create your Iceberg tables, you reference them automatically with the Snowflake hosted version of Polaris, which is Open Catalog. And then you can reference these tables directly from within Snowflake without having to do any manual catalog integration. The alternative to that is you can use the open source version of DLT, pick your own hosted catalog or host it yourself, register the data sets with that catalog, and then it's kind of one manual step in between. So you have to create this catalog integration between Snowflake and whatever you choose your cataloging to be. You have to create that integration manually once. But this is really just like the heavy lifting, like the creation of the tables, the metadata, all of that is done by the library. And then the last piece is this like cataloging step. and to connect the data with your query engine.
Okay. And then we'll do one last question here. We've got about 4 minutes left. So it says, did you mean you run DuckDB in your local server, and how to handle concurrency pipelines with DuckDB? I hope you know what that meant, because I don't.
You mean concurrency pipeline, like the transformation concurrency? Because we're using DuckDB only for the transformations. I think I'm not sure whether I get the question exactly right. But so far we haven't had any issues with I guess our data hasn't been that big for a single transformation to not be able to run DuckDB on a single node, if that is the question. I think we haven't been in that area.
Okay, I'm gonna hope that answered it. And then before we go, I just wanna, so there were a couple comments about the GitHub repos you mentioned. Are there specific terms they should search for, or do you have any URLs handy we can drop in the chat? Just so people can make sure they can find it easily on Google.
Let me check. Except on. So this is the example repo for the Lambda integration. Can I just drop this here into the chat?
Yep, go ahead. All right, so.
Portable data lake.
All right, I'm dropping these, everyone, in the join a conversation chat for everybody. So there's the GitHub for the Lambda.
Okay, wait a second.
Thanks for being patient, everyone, while we do some Google research on the fly.
Okay, let me, not sure whether that is actually open source. Let me check. It should be. Otherwise, I'm going to publish it under my GitHub. So my GitHub you can find at Coding Cyclist. I'm going to put it up there, at least the version that I've been showing you today.
Okay, awesome. Well, that is all of the time we have. So thank you, Simon, for your time. It was a great session. Lots of good questions. But yeah, really appreciated you being here. Thank you so much. So up next in this track, we have the session from 0 to 1, building a petabyte scale data analytics platform with Apache Iceberg, presented by Andrew and Vijay at TRM Labs. You can also click on the agenda at the top and pick any of the other sessions that are happening next. You don't have to stay in this track. You're welcome to just bounce around and view what is most interesting to you. But yeah, thanks again, Simon. This was great. I hope you guys enjoyed the sessions. These will be on demand by the end of the day today. So if you had to pop out, you missed any of this, or you want to view any of the other sessions that have been happening during the event, just pop back into Visible and they'll all be available for replay. So with that, everyone, thanks and enjoy the rest of the event.
Thanks for having me.